Okay, so first of all, to differentiate sine cube theta, you need to make it sine theta to the power of 3. So it's like a reverse chain, like a chain rule. So you bring the 3 down the front and you go sine theta to the power of 4, and then you times the derivative of the inside. So it's 3 sine 4 theta cos theta. So that means that the derivative of sine cubed theta is equal to 3 sine squared theta cos theta. Okay, so now I'm just going to integrate from 0, x squared, 1 plus x squared, to the 5 on 2 dx. So if you let x equal tan theta, then dx on d theta equals sec squared theta. So that's going to get rid of the dx, because dx is just sec squared theta d theta. So it's going to replace that. X is equal to tan theta, so we can sub that in for these x squared and that's x squared. We've just got to do the endpoints. So if x equals 1, 1 equals tan theta, so theta is 45 or pi on 4. And if x equals 0, 0 is tan theta, so theta equals 0. So that means you're going from 0 to pi on 4 of x squared, which is tan squared theta, over 1 plus tan squared theta, to the 5 on 2, just replacing the x's, times, now in place of the dx, we're going to put sec squared theta d theta. So it's all in terms of theta now. We just have to simplify this expression. So it's tan squared, 1 plus tan squared is sec squared, so it's sec squared 5 on 2 times sec squared theta d theta, which is 0 to pi on 4, tan squared theta. Now if you did sec theta squared and you times it by an indice of 5 on 2, the 2 on 1 times 5 on 2 ends up giving you 5. So it's just going to be sec 5 theta. So it'll be sec 5 theta on the bottom times sec squared theta d theta. So cancelling here, 1 sec squared with the sec 5 will give you sec cube theta. So that means you've got 0 to pi on 4 of tan squared theta sec cube theta d theta. So let's change it all to sine and coses. So you've got tan squared theta divided by sec cube theta. Tan squared is sine squared theta on cos squared theta. And sec cube theta is 1 on cos cube theta. And then if I flip that, because it's dividing by the fraction, sine squared on cos squared theta times cos cube theta on 1 d theta. And it's the integral from 0 to pi on 4. So the cos squared will cancel with the cos theta. So now we've got sine squared theta cos theta d theta, and we're going from 0 to pi on 4. That is a reverse chain rule. Because you've got 0 over to pi on 4, you have sine theta to the power of 2 times its derivative cos theta d theta. So it's like having f of x to the power of n times f dash x, which ends up being f of x to the n plus 1 on n plus 1. And then you go from 0 to pi on 4. Okay, so that means that we go, it's going to be sine 3 theta on 3, because you add 1 to the indice, because the derivative of sine is just cos, from 0 to pi on 4. So it's sine pi on 4 cubed on 3 minus sine 0 cubed on 3. Sine 0 is just 0. Sine pi on 4 is 1 on root 2. So we've got 1 on root 2 cubed on 3 minus 0, which is 1 on 8, root 8, and then divided by 3. So it's 1 on 3 root 8, which is 1 on 3 times 2 root 2, which is 1 on 6 root 2. You could leave it like that, or you could rationalise times root 2 root 2. which is root 2 on 6 times 2, which is root 2 on 12.